Hi everyone and welcome back to my channel in Economist. So this video is a continuation of our previous video where we have discussed what is limit and we have also gone into some of the questions. And in this video we'll be starting with question number 3, which says discuss the limit of function if x is mod x at x equals to 0 and draw its graph. So if you know the properties of mod, it can be written as if x is x when x is greater or equals 0 and it is minus x when x is less than 0, right? So this is how we can write if x is mod x. Now if you want to find the limit at a point 0, what you have to do, first find out left hand limit at x equals to 0, and what will that be? Limit x tending to 0 minus if x. Now from the left hand side the value is minus x, so put minus x here. What will be the value? Put 0 instead of x, so you will get 0. Now if you find the right hand limit at the point x equals to 0, it will again give you 0. Let's do that. 0 plus, now from the right hand side the value is x, so you have 0. Just put 0 in place of x. So what you see is that the left hand limit is 0, the right hand limit is also 0, the values are equal. So you will say that the limit exists at point x equals to 0. What will be the graph of the function? You know that graph of the function mod x, y equals to mod x, or you can write in this way. So this is the function, right? It looks like this, and if you see from the right hand side the function meets at this point x equals to 0, from the left hand side also it meets at this point x equals to 0, and this function is continuous here. Okay, let me go to question number 4. Evaluate the right hand limit. You have to only find the right hand limit of the function f x, which looks like this at this point x equals to 6. So what you are told to do, you need to find limit x tends to 6 plus, because you have to calculate right hand limit fx. But the thing here is that, so if you want to find out x tending to 6 plus, you have to consider this particular interval, right? Now look at this function. If you put 6 here, what you will get? In the numerator you will have 0, and in the denominator also you will have 0. So when you have the 0 by 0 format, you cannot just put the value 6 here. It will be indeterminate in nature, right? So what you have to do here is that you have to write like this. Limit, take some h tending to 0 and evaluate the point at which you want to find the limit plus h. Now why plus h? Because we are trying to find out the right hand limit here, right? And just compute this. If you see, if h tends to 0, this value will be f of 6. So this is the same thing as we are trying to find here. So it is just another way of writing, and this format will be handy for dealing with these kind of situations where you have indeterminate form. Now compute this limit. Limit h tends to 0. Instead of x, write 6 plus h, right? What you have to write here, then you have 6 plus h minus 6 divided by 6 plus h minus 6, right? Just cancel these things out and you will be left with limit h tends to 0 mod h by h. Now one thing I forgot to mention, h has to be greater than 0. This is a restriction on h. So if you break this mod, then you will have only h. Okay, let me write here. Okay, limit h tends to 0. This will be only h, this will be only h, so this will cancel out and you will have 1. So the right hand limit at the point x equals to 6 is 1. I hope you understood the process. So here what you have to do, instead of x you have to replace the point at which you are trying to find the limit plus the value h, if you are considering the right hand limit, right? If you are considering the right hand limit. Now if you are told to find out the left hand limit, you would have done 6 minus h and compute that, you will get the left hand limit. This is the process you need to remember. Now this question is based on the left hand limit. I want you to give you as a homework. Please do this. Here the point is x equals to 4. So all you need to do is replace x by 4 minus h and then compute h tends to 0 if of 4 minus h, right? This will give you your left hand limit at the point x equals to 4. Why we are doing this? Because it is in the 0 by 0 form or indeterminate form. Let me do another question. Here you have this. Again, it is in the 0 by 0 form if you observe carefully. And you are told to find that limit x tends to 0 if x does not exist. Now, what is the condition for that? The left hand limit at the point x equals to 0 is not equals to the right hand limit at x equals to 0. As I have mentioned, that limit will only exist if these two values are equal, otherwise they are not. Limit does not exist, right? So find out left hand limit at x equals to 0. Now again you have to replace here because it is in the 0 by 0 format. Limit h tends to 0 f of 0 minus h, right? This is what you need to find out. So do that. Let me erase this portion. Okay. So here what you have to do, limit h tends to 0 if of minus h. So write minus h minus mod of minus h divided by minus h, right? So you are just replacing this thing in this particular form. Limit h tends to 0 minus h minus, here if you pin the mod it will be minus h only. So limit h tends to 0 minus 2h by minus h, so it will be 2, right? Minus minus will cancel out, h will cancel out, you will have 2. So the left hand limit is 2. Now let me find out the right hand limit at x equals to 0. So you have to find out limit h tends to 0 if of 0 plus h. That will be limit h tends to 0 h minus mod h by h, right? H minus mod h divided by h. Since h is greater than 0, this numerator will be 0 because it will be, okay, let me write another step for you. H minus h by h, which is 0, right? So the right hand limit of the function is 0 and the left hand limit of this function is 2. They are not equal, so this gives us confirmation that limit x tends to 0 if x does not exist. The reason is that the left hand limit and the right hand limit are not the same. Let me do another question. For what integers m and n does limit x tends to 0 if x exist? Now exist means the left hand limit and right hand limit are equal at x equals to 0. So let's do that. Let us equate left hand limit at x equals to 0 with the right hand limit at x equals to 0. Let me start with this. Limit x tends to 0 minus fx is what? Limit x tends to 0 minus. Now if you see from the left hand side, this is the function, right? mx squared plus n. Put 0 instead of x, so you will be left with only n. This will be 0, so you will be left with n. And limit x tends to 0 plus fx. This will be limit x tends to 0 plus, what will be the value? Nx plus m. Nx plus m. This part will be 0, so this will be m. Now since they are equal, what we can conclude is that for all the values where m equals to n, the limit of this function exists, right? So since we are equating the left hand limit and the right hand limit, we have done that and we get m is equals to n, and this will be your answer. I hope this is understood. If you have any questions, you can post me in the comment section. I'll answer that. And next we have some properties of limits. These are some algebraic properties which will be very handy. So I have listed it in a slide. So if let f and g are two real functions with a common domain D, then all these properties will hold. You can take a screenshot of this, or you can pause the video and take a look at this. So if you add, you take the limit on the addition of two functions, it will be, the limit can be separated for the two functions individually. The similar thing will be for subtraction, for multiplication, for product of two functions, for division. If you have this power fx to the power n, you can take the limit inside of this function and then take the power. Similarly, fx to the power gx, for this you have to take limit on both fx and gx, and similarly you can compare the limits of two functions. So this is about that. And then what we have is the L'Hopital's rule. Some people call it L'Hospital rule. You can call it as you wish. Now, L'Hopital rule is a very handy technique which are frequently used for solving problems. So let's see the concept, and in the next video we'll go into some of the problems on L'Hopital rule. What this rule says is that suppose you have two functions f and g which are differentiable. I have not taught you differentiability as of now, but just remember, I hope you know this from your high school lectures, that what is differentiability. Then what happens is that if limit x tends to c fx is equal to limit x tends to c gx is either 0 or it is infinite, either plus infinity or minus infinity, and this quantity has a finite value. If you take the differentiation of each of these functions and take the limit, and this gives you a finite value, then what you can say is that you can replace this limiting value with the value of what you get after the differentiation. Now from this definition it might seem very difficult for you, but as I solve some questions you will see it's very simple. And when it is used, you have to remember when this formula is used. Most common intermediate forms, when you see that a limit is in the form 0 by 0 or infinite by infinite, or 0 to the power 0, 1 to the power infinite, or infinite to the power 0, these are all some common indeterminate forms where you cannot simply put the limit instead of the variable value, instead of the variable itself, right? So in those particular cases you have to use this L'Hopital rule. Let me quickly solve one problem with you just to give you a sense of how it works. Here it says limit x tends to 1, x cube minus 1 upon x minus 1. Now if you put x in the numerator, x value 1 in the numerator and in the denominator, you will see you will get 0. 1 cube minus 1 is 0 and 1 minus 1 is also 0. So let's do this. Let fx is the numerator. It's a polynomial function. Fx is this, and consider gx to be the denominator function, which is this. Now what you have to do, you have to calculate the first differentiation. If you know the rule of differentiation, x to the power 3 is 3x square. And if you know the rule of this, it will be differentiation of x is 1. Now what this L'Hopital rule says is that this limit will be exactly equals to limit x tends to 1, 3x square by 1. That is, you are simply putting the differentiation value of these polynomial functions here, and if you calculate the limit, it will give you the same value. So just put 1 here, so it will be this, so it will be 3. I hope you got the process. And then what happens if you, now there could be a case that once you take the differentiation and still you get some indeterminate form 0 by 0 or infinite by infinite, in that case you have to again take differentiation, second differentiation, and then put the value, and just the process will continue like this. And we'll solve some other problems, some more difficult problems in the next session, and we will also see how to find out limits for infinite series, right, for exponential and logarithmic functions. So stay tuned for the next video, and if you like my video, then give me a thumbs up and do subscribe to my channel, and stay tuned for the next video. Thank you.